Hi everyone. Today we'll try to learn how to calculate a load of certain room or certain space. So for the single phase, it's quite easy to calculate the capacity of current, how much current will be, and what will be the wattage for that. So today I'll try to express or explain all these things in quite detail. So if you take a example over here, there is a three type of load while we are calculating. First is a lighting load, second is a power load. Lighting load in the sense like uh, that our tube lights, our 2 by 2 lights, or whatever fixtures we are using for the illumination of the space. Power load is a sockets, those we are using for the plugging of our mobile chargers, our fans, whatever that we connect through the sockets or comes under power load. So basically, uh, how we can calculate the what will be the load for the certain area or something. Suppose we'll take an example over here and we'll look into that. If we see there is a LED tube light, there is 8 number of tube light, and the wattage is around 16 watt, and the bracket light is 12 watt. Then if we multiply all these things, we'll get the 128 and 12 watt. After that, if we see over here, the total wattage is 140. Then we come to the power load. Suppose we have a 3 number of sockets, and each socket wattage we consider as per the standard is 200 watts each, so it's total 600 watts. So now we'll go to the total load connected. So lighting load is 140, power load is 600. Load in watt, if we go through if we sum all the power and light load, it will be 740. After that, we'll convert it into the kW. So it's very simple. You have to divide it by 1000. If you divide it by 1000, uh, we'll get the kW load. After that, we have to convert it into the kV. So for that, we have to divide it by 0.8. Here 0.8 is a power factor, as we know the formula P equals to uh, cos phi VI, or we can say power equals to kVA and power factor, which is cos phi. Then we have to convert this into load in ampere. For that, we have to divide the entire value by 184. It's a constant. Okay, you don't have to think much. It's a common practice that we use here 180 to get the per phase ampere for the single phase. Now load in HP. For the HP, you have to divide the value G9 value, which is 740 by 750. HP is horse in power. After that, we have to calculate the total load maximum demand load with 0.6 diversity factor. Diversity factor is nothing but how much time or what will be the running time of our load. So basically, you know that uh, we never use our lights or sockets 24 by 7. Usually we use it so whenever required. So we consider over here diversity factor 0.6. You can consider it 0.7 or 8. It's it depend totally upon the design engineer and what will be the usage of the system. Then after that, when you multiply this, we'll get a value at 84 and the power for the 360. Then when we will add it, then it will be 44. After that, uh, uh, after that we have to convert all these value again as we have converted above, so we'll get the load, HP and everything. So for the single phase load, our system will draw for this like for 444 volt, our system will draw around 2.4 volt 4 amperes, 2.41 amperes. So from here it is very simple because it's 440 volts. So basically for a one circuit we consider 800 watt as per the standard. So we can run a single circuit to get this work done. For the 2.4 ampere we can go with the uh, 4 square cable or 2.5, whatever is feasible. It's again depend on the design engineer what he wants to choose. So it's all about the today. If you want to know more about the load calculation for the single phase, you can comment in the box. I'll try to answer it. I'll try to clear your inquiries or your doubts if you have any. Bye for the day. See you in next lecture.